And this is a relationship that you're probably pretty familiar with. And that is that the sum of the angles in a triangle is equal to what? 180. Again, most of you have been exposed to this relationship before. What I want to do is take this statement, which right now, because we haven't proven it, is just called a conjecture. And I want to see if we can take this and formally demonstrate that it is always true. Okay, so let's say we take a triangle. And we'll call the triangle ABC, we'll give the angle measures A, B, and C just for easy reference. And let's take a line passing through point C, we'll call it line 1. Okay, and that line, when it forms these other two angles with the triangle, let's call those angles D and E, again, just for quick reference. Okay, so here's the things that we're going to start with to try to demonstrate that this conjecture is true. And that is, we're going to take triangle ABC. Okay, and then we have line 1 parallel to segment AB. Okay, and so from just this, we're going to see if we can prove that A plus B plus C is equal to 180. And can we prove this statement here? All right, so we're going to begin with our given statement. In triangle ABC, line 1 is parallel to segment AB. All right, as we go through this proof, what we're looking to do is we're looking to see, is there any way that we can introduce elements to give us this end state? Victoria. Okay, so the segment CB is a transversal. We don't have to specifically say that, although it is true, and if you said it, you wouldn't miss points for it. But if that's a transversal, then what other relationships have to hold true? Okay, so you know that B is equal to E, so that introduces this element. And what would be the justification, since these are parallel lines here? They're on opposite sides of that transversal, so it's IA. Okay, so alternate interior angles of parallel lines are equal, so B and E are equal. What other pair of angles are equal based on that same justification? D and A. Okay, so based on these, we have B and E are equal, D and A are equal. So we've introduced A. The last thing we need to do is introduce C and 180. And we'd like to get it in this form where three things add up to 180. Can we see that from the picture? Yeah, we don't specifically have a relationship that justifies that, other than the fact that what do you see that D, C, and E add up to? B, C, and E add up to 180 because together they form what? It's a straight line. So it's not really a linear pair, right? Because a linear pair would mean there's only two angles, but it's still based on that same concept of the sum of the parts is equal to the whole, and that whole is a straight line or a straight angle. And so we can say that here, just specifically say what it is. Three angles add up to straight angle. Okay, so in looking at that, you have those three angles adding up to the straight angle. So when we work to solve this, and I'm going to just adjust the order of these terms just a little bit. Victoria, question or statement? Okay, go ahead. Okay, so what can we substitute in for D? So D is equivalent to? So we can plug in an A. For E, we can substitute in a B. C can stay, 180 can stay, and we get our end state that we're looking for, and the reason is we just substituted in those values. Okay, and so here what we've been able to do in those is we've taken this conjecture, we've turned it into a theorem, okay, and when we use this, so now we can use this relationship in any future proofs, and when we use it, we can refer to it as triangle sum. It's just a nice short abbreviation for the same relationship, but that is the sum of the angles in a triangle is equal to 180 degrees.